Hello, good day to us all. Do you still remember me? I am E.L. Einstein. Have you ever wondered how to calculate or solve for speed, the wavelength, the frequency, and period of a wave? Well, in this video, we will be discussing just that. Well, what are we waiting for? Let's start! Today we will be discussing how to calculate the speed, wavelength, frequency, and period of a wave. But first, we have to know their signs. So what are their signs? For speed, its sign it is a lowercase v. For wavelength, it is a Greek letter known as lambda. For frequency, it is a lowercase f. And for period, it is an uppercase t. Make sure it's uppercase because if it's lowercase, it would be understood as time. They're different. Now moving on to their standard units. Their standard units are, for speed, it is meters per second. For wavelength, it is meter. For frequency, it is per second or hertz. And for period, it is second. Now, moving on to their formulas. First, we have the formula for speed. Formula for speed is equal to wavelength times frequency, or it can also be written as this. When two variables are put together, it is understood that they are multiplied. Now, moving on to our formula for wavelength. Formula for wavelength is equal to speed divided by frequency. Now moving on to the formula of frequency. The formula of frequency could be frequency is equal to speed divided by wavelength. And this is if the speed and wavelength are given in the problem. But we can also use frequency is equal to 1 divided by period if the period is given. And now lastly, moving on to the formula of our period. Formula for a period is simply period is equal to 1 divided by the given frequency in the problem. So I hope you all got that in your head, or if you noted that down, I hope you all got those formulas since we'll be using them later on in our video. Now, next up, we have our tips for solving. And our first tip is to easily remember formulas. We may use this triangle. On top is the speed, the bottom left is wavelength, and on the bottom right is the frequency. So let's say, for example, that the speed is what you're missing, or speed is what you're looking for in the problem. Then we may simply multiply the wavelength and frequency given. Now, let's say, for example, that wavelength is missing. Then you may divide the speed by the frequency. And lastly, if the frequency is missing, then you may divide the speed by the wavelength. And in the end, this is what it looks like. So, I just taught the formulas, and now this is just an easier way to remember them. Now, moving on to our second tip, these are speeds that may be seen in problems at room temperature. This may be seen in our sample problems later, so you may note this down. I will allow you to pause the video to take down notes and to give yourself more time to further understand these. So, here it is. Okay, I hope that was enough time for you. But next, we are done with our tips. So here we now have how to solve. And we will be using a method in our solving known as the Gressa method. But Mr. E.L. Einstein, what does Gressa mean? It's simple. G stands for given, R stands for the required in the problem, and E stands for the equation or the equations that you're going to use in the problem. S stands for the solution, and A stands for the answer. And here I have provided a sample for you to further understand the Gressa method. For example, you may pause to read to give yourself more time. Here it is. Okay, I hope that was enough time for you. But now that I have given how to solve using the Gressa method, I have shown you the formulas, the signs, and the things that you need in order to solve. We will now proceed to our problems. Test your knowledge. By the way, calculators are allowed since some of these problems are quite hard to solve in your head. So first, we have problem 1. I will give you 30 seconds to answer each question, and you may pause the video. Here it is. Alright, time is up. Now, let us solve this problem. So we have here the Gressa format. Our given is the speed of sound in water at room temperature, which is 1,500 meters per second, or 1,480 meters per second. I showed this earlier in our tips. And our second given is the frequency of 500 hertz. The required in the problem is the wavelength. Calculate the wavelength of the wave. And our equation for wavelength is equal to the speed divided by the frequency. Our solution would be the wavelength would equal to 1,500 meters per second, the speed, divided by 500 hertz, the frequency. And this would leave us with 3 meters, or 2.96 meters if you used 1,480 meters per second instead of 1,500. Right? Hope you got that. Moving on to our second problem. This problem may be quite more advanced, but I'm sure that you will get it. So here's the problem. I'll also give you 30 seconds to answer this problem. Here it is. Okay, time is up. Time to solve. So our given here, the distance between two successive crests, that is the wavelength, which is 3.3 meters. So our wavelength is 3.3 meters, and our period, one wave takes 3 seconds. That is our period, 3 seconds. And our required in this problem is the speed and frequency of the wave. In our equation for the speed is equal to frequency times wavelength, or wavelength times frequency. And our equation for frequency is equal to 1 divided by period, since period is given and there is still no speed in the problem. And now let us now solve. So our solution is frequency is equal to 1 divided by 3 seconds, which is equal to 3.33 hertz. And so now we have the frequency. Now we may solve for the speed. So our speed is 3.33, our frequency, multiplied by 3.3, our wavelength. And that would give us 10.989 meters per second. And if you did that all correctly, your final answer should be frequency is equal to 3.33 hertz, and our speed would be 10.989 meters per second. If you did that right, good job. And now, moving on to our third and final question. I will give you 30 seconds again to answer this question, and your 30 seconds start now. Okay, I believe that your time is up now. It's time to solve. Our given is, well, here we have our aggressive format, but our S and A are in another slide since it didn't fit. So our given is the wavelength, which is 20 centimeters, and our velocity, which is 20 meters per second. And our required in this problem is the frequency and the period of the wave. And our equation for frequency is equal to the speed divided by the wavelength. And our equation for period is equal to 1 divided by frequency. And our solution is we first have to convert the 20 centimeters to 0.2 meters, since meter is the standard unit of wavelength and not centimeter. And now we have that. We may solve for the frequency, just the speed divided by the wavelength. 20 meters per second divided by 0.2 meters would equal to 100 hertz. And now that we have the frequency, we may now find the period. And now we just have to divide 1 by the frequency, 100. And that would give us 0.01 seconds. Now if you did that all correctly, your final answer would be frequency is equal to 100 hertz and period is equal to 0.01 seconds. I hope you got all of that. You may use this in your future lessons with your teacher, or if you encounter a wave problem, you may use
That is
the
all.
things that I have
I
taught you
hope you
in
learned
this video.
something. And always remember that every problem always has a solution. Once again, this is E.L. Einstein signing out.